Question number 9, it says, in the diagram below, E, C, G, and F are points on the circumference of a circle. EG is a diameter of the circle. The tangent EAEB is parallel to CD. The angle AEC is 68 degrees, and the angle EFD is 106 degrees. So all that they just said, we can see in the diagram. Determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. We're asked to determine the size of angle ECD. Angle ECD. So this is the angle they want us to find. All right, angle ECD. So this angle is what they want us to find. All right, and this angle is equal to 68 degrees. And the basic reason is that the two angles are alternate angles. The two angles are alternate angles or Z angles. So I would say angle ECD is equal to 68 degrees. And I would say that angle ECD and angle AEC are alternate angles. So I'm asked to give a reason. That's my reason. There are alternate angles, and alternate angles are equal. All right, so let's move on to the next part of the question. We need angle CEG. Angle CEG is identified. CEG, we need this angle. CEG, we need this angle. All right, I'm going to use the fact that OEA, angle OEA is 90 degrees. I'm going to use the fact that angle OEA is 90 degrees. So I'm going to say that angle CEG is equal to 90 minus 68. And this is what is it? 22 degrees. And I'm going to tell him the reason for that is that angle OEA is equal to 90 degrees. Why? Because the radius at the point of contact is at right angles to the tangent. All right, so that is a circle theorem fact, or it's a theorem, it's a circle theorem, that the radius at the point of contact is at right angles to the tangent. The next thing we want is angle CGF. Angle CGF, we need this angle here, CGF. All right, I know how to find that. The quickest way I can think of finding that is to find this entire angle here. Is to find this entire angle. And to find that angle, I'm going to use the fact that this angle here, CGF, I'm going to use the fact that we have alternate angles here. So if these are alternate angles, it means that this entire angle here is 106. So if the entire angle is 106, this internal piece, let me call it alpha, or angle CEF. So I'm going to first say angle FEA is equal to 106, alternate angle. Angle FEA is equal to 106, alternate angles. Then I would say that angle CEF, angle CEF is equal to 106 minus 68, which is equal to how much? How much is that? $38. All right, so let's just get, so the entire angle in here is 38 degrees. Now, CGFE is a cyclic quadrilateral. CGFE is a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral are supplementary. So if this is 38, the one down here is 38, the one up top would be 180 minus 38. So angle CGF, angle CGF is equal to 180 minus 38, which is equal to 142 degrees. And the reason I'm going to give is that angle CEF and angle CGF are opposite angles of a cyclic quadrilateral. And opposite angles of a cyclic quadrilateral are supplementary. Which means that they add up to 180 degrees. All right, B part of the question is on bearing. It says from a harbor H, the bearing of two ships, Q and R, are 69 degrees and 100 and 151 degrees respectively. Q is 175 kilometers from H, and while R is 242 kilometers from H. All right. We're asked to complete the diagram by inserting above to show the information given. The only other thing that is missing is the 100 and what? The 100 and the 151 degrees. Bearing is measured clockwise from north. So starting from north, around to the line that connects H and R, it's 151 degrees. All right, so we did that already. Then it says calculate the length, the distance between the two ships. The distance between the two ships is QR. We need to find the distance QR. Now, to find that distance, I need this internal angle here, which is 151. Let's call it alpha. Alpha is equal to 151 minus 69 degrees. So alpha is 82 degrees. So this is 82 degrees. So we have 82 degrees here. So right now what we have is a triangle, a non-right angle triangle, for which we know the length of two sides and the inclusive angle. And we want to find the length of the third side. So for that, we're going to have to apply the cosine rule, which says that c squared is equal to a squared plus b squared minus 2ab cosine c. Now in this formula, this is little c. The 82 degrees is big C. This is A and this is B. So we have x squared is equal to 175 squared plus 242 squared minus 2 times 175 times 242, the cosine of the angle between them, which is 82 degrees. If you put that in a calculator and press equal, you're going to get x squared is equal to 77,401.04. The opposite of square is square root. So x, which is QR, which is the distance between the two boats, is equal to 278.2 kilometers. Next, we're asked to calculate how far south is ship R to the harbor H. How far south is R from the harbor H? So if I continue my north-south line, let's continue my north-south line down. All right, let's erase a piece of this. This distance here, x from here to here, that is how far south R is from H. That distance is how far south R is from H. This angle here is 90 degrees. So the distance Y is how far east, and X is how far south is R from H. So we need to find that distance. So for starters, I need this angle. Let's call it theta. Now, theta would be equal to 180 minus 151. Theta there would be 29 degrees. Remember, I'm trying to find X, and this angle here is 29 degrees. X is adjacent to this angle, and the 242 is the hypotenuse. The trig ratio that includes adjacent and hypotenuse is cosine. So I'm going to say the cosine of 29 degrees is equal to adjacent X over hypotenuse 242. If I have one fraction is equal to one fraction, to get rid of the fraction, I'm going to cross multiply. 1 times X is X is equal to 242 cosine 29 degrees. X is equal to 211.7 kilometers. So how far south is R from H? The answer, it is 211.7 kilometers south of H.